Yo, this is Naireza Alvin, and today we're going to look at two things. The first thing we're going to look at is the generation of computers from the first generation to the present. And the second thing we're going to look at is I want us to look at the development of Intel x86. So first, let's dive into the generation of computers. So the first generation, to start with, these computers, they used vacuum tubes for circuitry, and then they used magnetic tapes and magnetic drums for memory, and basically they used machine language as a programming language. You know that machine language, that binary code. Yeah, that's what they used. And the other thing they would consume a lot of electricity and generate a lot of heat. And another characteristic, they were very, very expensive. So let's go to the second generation. Before we look at the second generation, these first generation computers, they lasted from 1940 to 1955. I shouldn't forget that. And then for the second generation, to start with, it lasted from 1959 to 1965. And for them, they used transistors that were cheaper. For them, they were reliable and faster compared to the first generation computers. They had the smaller size compared to the first generation computers, consumed less electricity. For them, they used magnetic cores for primary memory and then magnetic tapes for secondary memory. They used high-level programming languages such as Fortran, which is formula transition, COBOL, that is common business-oriented languages. So that's basically about that generation computers. So let's go to third generation computers. The third generation, it lasted from 1965 to 1971. And for them, they used integrated circuits in place of transistors, you get? And then for them, they were of smaller size, they were more reliable, more efficient compared to the previous generations, and they were more cheaper, way cheaper compared to the previous generations. So that's basically about third generation computers. For the fourth generation computers, let's take a quicker look at fourth generation computers, and for them, they lasted from 1971 to 1980. Yeah, 1980. So for them, they have microprocessor based systems, and another thing, they have improved speed compared to the previous generation computers. They have high level of accuracy if you compare them to the previous generations. Then they have high level of reliability, if you compare them to the previous generation computers. For the fifth generation, when I talk about the fifth generation, I want to talk about from 1980 up to date, because when you see computers from 1980 up to date, they don't differ that much. They really don't differ. So let me talk about the fifth generation, that is from 1980 up to date. So for them, they use artificial intelligence. That is development of expert systems, gameplay, robotics, natural language understanding, among others. So that's basically about fifth generation computers. And one more thing about fifth generation computers, they have connectivity, automation, secure networking, efficient data transfer, to mention but a few. These include laptops, notebooks, mobile phones, name it. That's basically about 5th generation computers. And another thing we're going to look about today is the evolution or the development of Intel x86. So let's dive into it. First, Intel 86 started in 1968 by Robert Noyce and Gordon Moore, that guy of Moore's Law. You remember that Moore's Law? So the 4-bit CPU was launched in 1970, and that was Intel 404. The 16-bit CPU was released in 1978. So from there, they had to launch the 32-bit CPU with protected mode, and it was released in 1985. Then 486 came in 1989, came along with clones from AMD and Cyrix. So from there, Pentium, that is 586 in 1993, plus clones. It also had clones. Then Pentium Pro and Pentium 2, Pentium 3, that is 686 from 1995 to 1997. That's when they were launched, released. So from there, we had to see Pentium 4 in 2000. And in 2001, Intel tried to escape x86 and launched the doomed 64-bit Itanium. And in 2003, AMD releases Athlon 64 with the AMD 64, that is 64-bit instruction set. So from there, in 2004, the Intel's version of 64-bit x86, that is EM64T, that's when it was released. So when you take a quick look at the history of x86-3, so in 2005, Apple moves from PowerPC to Intel x86. In 2006, first Macs with 64-bit Intel processors, that's when they came in. And from 2008 to present, that's where i3, i5, i7, i9 came in. So in 2020 of recent, so Apple moves from Intel x86 64 to its own chips based on ARM. That's where ARM comes in now. Talking about ARM, that is Argonne RISC Machine Project. And for RISC, it stands for Reduced Instruction Set Computing. And ARM, it was started in 1983 by the Argonne. So ARM1 used the plastic package, to keep the cost very low, And then ARM2, it came in 1987, and the first consumer computer based on an ARM chip. It was the Argonne Archimedes. That's the first consumer computer based on ARM. That was Argonne Archimedes. So Some people confuse ARM with Intel, but there are some differences. Basically, ARM differs from Intel, just as we've seen. Okay. And one of the differences I can give between the two is that Intel manufactures its own chips. Well, for ARM, what it does, they design CPU and GPU cores and license them to other companies like Qualcomm, Samsung, talk of MediaTek, and many others. Another difference you may talk of is that Intel x86-64 is CISC. It's abbreviated as CISC. That is complex instruction set computing. While ARM is RISC. It's abbreviated as RISC. That is reducing instruction set computing. That's another difference you may look at. And I would like to talk more about the CISC and the RISC. So let's first talk about the CISC. For the CISC, that is complex instruction set computing. For it tries to do more in one instruction. For it has complex multi-stage instructions. Then it tries to make the CPU more like the software, And then for the CISC, historically memory was expensive and slow, and the variable length instructions that they had, that is up to 15 bytes long. Talking of the RISC, that is the reducing instruction set computing. For it tries to do one thing only per instruction. So it has simpler instructions compared to the CISC. It tries to take one instruction per cycle, and it has fixed instruction cycles, unlike the CISC. That's it basically. And before we end, let's take a quick recap on what we talked about. Remember, we started with the evolution of computers. We started with the first generation from 1940 to 1955, remember? And then we talked about the second generation computers. We also talked about the third, up to the fifth, to the present. We say the present includes the laptops, the notebooks, mobile phones. Mentioned but a few. From there we talked about the development of Intel x86 and ARM. And we concluded that ARM was boosted by Apple. Apple came in and boosted the ARM. So that's it basically for today. Remain your boy Nahereza Alvin. Yeah, God bless.